watch this video on YouTube for as a review. Yes, it's a video. Okay. And it follows me much. Woo! Wow, right? Super cool. Okay. So, I don't think you can because I might get sued for posting a minor's face on public space. Well, okay, so here it goes. First step, guys, we are trying to identify the limiting reactant in a reaction. So this means you have two or more reactants coming together, and one of them is going to run out before the other and stop the reaction. Just like one of our reactants in our hot dog making thing ran out, so the hot dogs ran out, so we stopped our reaction of making complete hot dogs. Make sense? Okay, so in this case, we're going to pick one product, and this will make sense when you guys see the actual example done through. Step 2. Okay, you're going to do 2 stoichiometry problems, one for each reactant. Solving for the chosen product. Okay, and then finally step 3, compare amounts of product formed. Okay, and then the reactant that made the least amount of product is going to be the limiting one. I know this makes next to no sense just as words. I'll show you an example once we get it copied. You think you get it? Cool. Okay, so let's just walk this through in terms of concepts with the hot dogs again. Okay, so what's the product that we make when we have hot dogs and buns? Yeah, the complete hot dogs, the bun within the dog within the bun, right? There's only one product, so that's our one product. We would do 2 problems. Okay, our 2 problems are, if we start with 7 hot dogs alone, how many complete hot dogs could we make? 7. And if we started with 10 buns and didn't worry about the hot dogs, how many complete hot dogs could we make? 10, if you had unlimited hot dogs, right? So which one made fewer complete hot dogs? The meat part or the buns? The meat, right. And so that's step 3, comparing the amount of product formed. Okay? Now, if that doesn't make sense, here comes a chemistry example. Okay? Okay, I'm going to copy this to the board. You guys already have it on your paper. I'm just going to put it on the board. So we have 2 Na. 2 N. Hey, Jen.
Follows her.
All right, guys, so I put this in shorthand for you guys. You have the whole sentence written out. So on your papers it says, suppose 6.7 grams of sodium reacts with 7.2 grams of chlorine in the following reaction. Okay, what is the limiting reactant and how many grams of NaCl are produced? That's what we're trying to figure out. So, step 1, we're going to pick a product. What's the only product we can pick for this reaction? Yeah, that's the only product we have. Sometimes there'll be several products, sometimes there'll be just one. So in this case, we're going to be solving for NaCl. Step 1, done. Step 2, we're going to do 2 stoichiometry problems. Jana. We're going to do 2 stoichiometry problems, one starting with the Na. Okay, so our given amount of NaCl, starting with a given amount of this to figure out how much product we can make, and then starting with a given amount of this to figure out how much product we can make. So here comes the actual math part. And so 6.70 grams of Na. Now how we've done this with stoichiometry, what's my next step? If I'm eventually trying to figure out how many moles grams of NaCl I can make. What's my next step? Put it into moles. I have to do this into moles first. So 1 mole of Na weighs 22.99 grams. That's my first step. That gets me into moles. What is my next step, guys, if I'm trying to get to here? My mole ratio step. Thank you very much, Alondra. So, Alondra, what is my mole ratio going to be? 2 over what? 2. 2 over 2. So we have 2 moles of what I want. I'm looking for NaCl, so it's going to go on top. NaCl over 2 moles of Na. We are now into moles of this stuff, so now we're going to put 1 mole on the bottom, NaCl, and then the molar mass of NaCl on top, 58.44 grams of NaCl. Okay, doing that math out, I get 17.
Wait, where'd you get the 58?
That's the molar mass of NaCl.
How'd you know that?
I did this 3 years ago when I made my note packet. Okay, you can tell I've got coffee stains on it. That's how you know how old things are. Eventually, everything I own gets coffee spilled on it. So if it's got a coffee stain on it, I've had it for a while. Okay, that's our first stoichiometry problem. Now we're going to do the next stoichiometry problem. This time, we're going to start with the other reactant that we're given to work with. So now I'm going to 7.20 grams of chlorine. And I'm going to be going to the same product that we chose for the first one. So I'm going to NaCl. So first step is going into what? Grams into moles. So I have to divide by my molar mass of Cl2. So 1 mole of Cl2 is 70.9 grams of Cl2. And then mole ratio step time, right? We're looking for the NaCl, so that's going to go on top. And then the Cl on the bottom, 1 mole Cl2. And then the last step will be the same because it's the same molar mass, 58.44 grams of NaCl, 1 mole of NaCl. Woo! Okay, and then doing all that out, we end up getting 11.87 grams of NaCl. Okay, so we've done our 2 stoichiometry problems. So here's the final part. I'll wait and let you guys copy this. What's up? This was given to us in the problem. Okay? Okay, so before I dive any deeper into this, guys, I want to make sure that we're all on the same page here. Okay? What we just did was say, okay, I'm starting with this amount of my reactants. One of them will run out first and stop the reaction. Our question is, which one runs out first? So what we do is 2 stoichiometry problems starting with our given amounts, and then we figure out how much product each one can make. Okay? So now we take a look. Okay, so if we start with Na, we can make 17.03 grams. If we start with chlorine, we can make 11.87 grams. So which one made less product?
Chlorine.
The chlorine. So this guy is less product. So the Cl2 is the limiting reactant.
Wait,
So the chlorine is the limiting reactant. Isaac.
If it's like CuSO4 or something with 3 things, do you have to do the 3?
If there's 3 reactants up here?
No, if the product we're looking for is like NaClO.
NaClO, like an O written here?
Yeah. And
That would just, the only thing that would change is the molar mass.
Well,
But if it were, are you saying?
Would you have to do the stoichiometry problems for the oxygen as well?
Oh, you mean if there's like another product, like a
No, the product is just bigger. The product is just NaClO.
Then the only thing that would change is the molar mass of the.
No, but would you have to do 3 stoichiometry?
Would you have to do 3 because there'd be O on the end?
Oh, no. Like if there was an O written here?
Yeah, would you have to?
Yeah, but then there'd have to be oxygen on the other side.
Yes. So that would mean then you'd have like O2 over here.
Yeah.
Yeah, and then you'd have to do a 3rd problem.
And then you have to do 3 straight.
Right.
But
Yes.
Are we gonna have to do those a lot?
No, usually it's just 2. Okay? So guys, really quick, a big mistake that people make every year with this is they say, okay, less product was made, so this one is the limiting reactant. And they're like, NaCl, that's the limiting reactant.
That's a product.
Thank you. Okay, what was the problem with that statement? NaCl is a product. It can't be the limiting reactant. It's not a reactant. Okay, so pay attention to that. People make that mistake every year. Okay? All right, right, Casey? Right? Nick, yes? Okay, so guys, the last question, what was the last question? So the first was, what is the limiting reactant? The second question was, what is it in the problem? How many grams of NaCl are produced? So which one are we actually going to make? So these two things come together. Are we actually going to make the 17.03 grams, or are we actually going to make the 11.87 grams? 11.87, because once we use all the chlorine up, it's got to stop. Just like how once you use all the hot dogs up, you got to stop making hot dogs. Okay?
There you go.
All right? So there it is. So now we know we can only make 11.87 grams. Are we good to go?
We're ready to go.
Okay, so let's try this again. Do you guys want me to walk you through the second problem, or do you want to try it on your own? I heard some yeses. You have plenty of time to practice on your own with the homework, so we'll walk through this next one together as well. And then if you want to try on your own, go ahead and try on your own. And then we'll see. Oh, I shouldn't have erased my steps. Well, you have them in front of you guys. They're on your notes. So here it goes. Yes. Yes, you can. Okay, so next example, here it goes. We have this reaction going on. 2Cu plus S, and then Cu2S. 80 grams. Okay, so guys, let's take a look at what this problem is telling us. Okay. We've got this reaction in front of us. We have two reactants, one product. It's giving us a certain amount of each of our reactants that we're going to start with. And it's the same question. Which of our reactants is limiting? So which one is going to run out first? And then how much of our product can we make? Okay, so first step, step one, we pick a product. Which product are we going to pick?
Copper sulfate.
Copper sulfate. Oh, look at that. It's the only one. Okay, so we have to solve for that one. Again, if there's a problem with multiple products, you just pick one. It won't matter. You can pick any product you want. But in this case, we only have one product, so that's that. That's step one. Step two, we're going to do how many stoichiometry problems? Two. One for each of the reactants. So I'm going to start with my copper, so 80 grams of copper. And I'm going to divide by the molar mass of copper to get into moles, which is 63.55 grams of copper. The next step, I have to get into my product. Remember, we're solving for the product, so I'm going to use the mole ratio between my product and what I'm starting with. So 1 mole of Cu2S, and then over here I have 2 moles of copper. And the last thing, I'm going to get into grams of my product. So now I'm going to do product on the bottom and 159.16 grams, and that will get me 100.18 grams of Cu2S. Questions how I set that up? Shaquan, you look so into this right now. You're like digging it up. You following? Okay, you copying this? Yeah? Okay. All right, what's my next step? Alondra, what am I doing now? The sulfur one. So I'm going to start with sulfur. So 25.0 grams of sulfur. 1 mole of sulfur weighs 32.06 grams.
Yeah, I just need one example.
Okay. And then we're going to product. So this product we have 1 mole of. And over here we have 1 mole of. And then turned into grams. And then 159.16 grams. Okay. And then we end up getting 124.11 grams of Cu2S. All right. I'll wait till you guys get this copied before I continue.
Are you sure about that?
I am sure about that.
I didn't get that.
I didn't ask.
You got it too?
Maybe you're just wrong.
Hey, be nice.
So
Hmm.
I eliminated.
No, I'm sorry.
Hold on.
But I get it.
Okay. So on the count of 3, let's see if everyone got it. On the count of 3, tell me what the limiting reactant is. 1, 2, 3.
Copper.
Raise your hand if you think it's copper.
Yeah, it's copper.
And sulfur. Very good. Okay. So guys, this was the smaller amount. So this means
This is the limiting.
copper is limiting. Hey guys, is the Cu2S the limiting one?
No, it's copper.
Great, because this is the product. Very good. Guys, last question. Please stick with me here. Ethan.
Yeah.
Last question. How many grams of our product can we make? Nick.
100.18.
Good. So whatever the smaller number is, that's how much we can make. Okay? All right. We feel okay on this, guys? Yeah?
So how many atoms is that?
Well, we could do that.